I'm going to try to determine all intercepts and asymptotes, and then I'm going to try to give as much of the graph as I can without using the graphic calculator. So I like to use my favorite question everywhere. What makes 0? And what I mean is, what x makes 0? Right off the bat, I'm looking at something where I can see what x makes 0. What x makes 0 in the numerator? So I like to say, what makes 0? Okay, what x makes 0? And that is a -2. Yep, all of the what makes 0 answers up here, all of the what makes 0 answers up here are in the numerator are going to be our x-intercepts. So I now have that this is an x-intercept. Okay, so let's go ahead and mark it. I know it's going to cross at -2. The one exception is maybe it's a hole. So just keep that in mind from our old lessons, that maybe there's an x plus 2 down here, which would be removed, and therefore it's not an intercept, it's a hole. Okay? Let's double check the bottom now. Let's see if we can figure out what makes 0 on the bottom. Best way to do that is to factor it. Okay, now, down at the bottom. Let's go ahead and factor that. Down at the bottom, I see we've got an x. I always set it up this way. I look at my factors of 3 and 1. Okay, and I try to figure it out. Since they're only 3 and 1, let's go ahead and put them in. Okay, do I have a difference? Focus here on the -3. The minus means it's going to be a difference. So I have a difference of 2 in those factors. Cool, make sure we get the +2, so that means the bigger number needs 3, and the smaller number needs the negative. So that's the way I always factor these. Now, what makes 0? Whoops, didn't write that well. What makes 0? I like to use W and Z for this. What makes 0? What x value plugged into these guys would make 0 out of the denominator? Okay, -3 and 1. So now I'm going to have a vertical asymptote at -3. Vertical asymptote at -3, and I kind of missed my line. Let's see if I can scoot that over. Ooh, can't. Cool. Okay, and 1 at, where's the other one at? 1. Excellent. So we're going to put 1 here. So vertical asymptote at 1. We're starting to build all the little aspects of this. We want to talk about the asymptotes. Well, actually, yeah, we're still kind of bouncing around here. I am bouncing around, I apologize. So let's talk about the possibility of horizontal or even a slant asymptote. If we plug and chug big numbers here, I like to say gazillion. If I plug and chug gazillion, I got basically a gazillion over gazillion squared, which we talked about. What will that thing go to? That will go to 0. So because of these two most powerful things, basically it simplifies to 1 over x. And if I plug and chug a big value there, that's clearly going to 0. So now I have an asymptote that is on the x-axis, that is y equal 0. Go ahead, ask. A good question just came out. Eli just asked. What was that question again, Eli? Ask it again. Yes. Good question. How can I have an x-intercept on y equals 0? You have to understand horizontal and slant asymptotes. Horizontal and slant asymptotes, right? They actually control our end behavior at gazillion. So I can cross the asymptote, what I say is locally, nearby origin. But at end behavior, at a billion or a gazillion, I like to say, it really is a kind of a made-up abstract word, but is in the dictionary. A gazillion plugged in would really want to level off at 0 somewhere, try to level off at 0. So that's what's going on. Let's see now. I've got the horizontal, I've got the vertical, I got the x-intercept, y-intercept. Plug and chug. 0. So we want to know what g of 0 is to get the y-intercept. This will get me the y-intercept. Okay? And so if I plug in 0, 0, 0, you can see it. It's at 2 over -3, so I'll call that, as I heard, -2/3. Let's find that point. Let's go ahead and approximate it right there. Now, we've got all our asymptotes. We've got all our intercepts. We've pretty much determined as much as we can without physically graphing it. So keep in mind, keep in mind the mama 1 over x, and honestly, the plus or minus mama. Okay, keep in mind the 1 over x graph. Okay, and I mentioned the plus or minus 1 over x graph, as we call the reciprocal graph, and that's a quick little sketch of it. That's in general, what they feel like. Sometimes they're flipped, sometimes they look like this. So I want you to see how we have broken up. We have broken up the graph into 6 quadrants. And the first logical thing you have to understand is the graph can't be on top and bottom. Because if I have a graph up there that's continuous and a graph down here that's continuous,
It's not a function.
beautiful, not a function. So I just need to figure out, is the graph up there or down here? Down here.
The graph
In the middle, they tend to look funky. They could be like parabola looking. They could be cubic looking. They tend to look funky. And I'm always a little unsure over here.
I think it's parabola.
Over here, the graph is either up above or down below. So again, it can't be both. Okay? So let's take a look at the far left side, left of -3. If I come back to this graph and I'm looking at it and I say, okay, let's plug and chug a big number, is the numerator, okay, if I plug and chug a negative value in there, so if I put a negative into the x value, like a negative big number, and a negative into the x value down there, this is like our even test, right? This is like our symmetry test, right? And a negative in here, excuse me, that's supposed to be 2 times negative x. Can you guys tell me if this answer is positive or negative?
Negative.
Does everybody see it's going to be negative? Okay, will this answer be positive or negative?
Negative.
Think so?
No, it's going to be positive.
Big negative number, controlling it on the bottom is x squared. So big negative number on the bottom is being controlled by x squared. Therefore, it is positive, right? At the big numbers. I mean, down small numbers, I could probably produce a negative down here. But right here, because of the x squared, that guy is going to be positive. Up here, this is going to be negative. I now know where the graph is. It's got to be below. And since it looks like the reciprocal graph, I guess, and I want to emphasize that, I guess, partially assume that the graph is going to flow like this. I may be right, I may be wrong, but this is part of learning it until we get to the more thorough calculus approach. Okay? How about over here on the other side? Let's plug and chug big positive numbers. So all these are positive. What will the value be? Positive or negative?
Positive.
Perfect. Now I know the graph exists over here. If you actually get to this point of the homework and you got that part of the graph, that's awesome. The other side of it with these intercepts, or the inside of it with these intercepts, the graph may, and I really don't know here until I do a little more investigation, it may want to do something like this. Okay, it may, but I just want to give you another choice. Okay, it may come up and do kind of this parabola bouncing thing.
Yeah, that's right, Mason.
Okay, so there is a couple of choices here.
Yeah, that's what mine said.
That is, shh, you guys are doing great, hold up. That is really, okay, part of what we do in calculus is try to figure those out. Okay, it is a limit as we approach these questions. So let's take a look at this next problem. Let's take a look at this next problem. And I'm just going to go through it as fast as I can, and anything I see, I'm going to plug and chug zeros. So I'm going to think about this guy being 0, this guy being 0, this guy being 0. What's my y-intercept?
2.
2, right? So I got a 2. Let's talk about the x-intercepts. Let's talk about what makes 0 on top. It's 2x, and let's hope this breaks down. Does it break down? No, it doesn't. So we're going to have to do quad form. Remember, I get unhappy here because now I got to do quad form. So the actual intercepts on this one are going to be -1 plus or minus the square root of 1 minus 4 times 2 times 2. So what is that? A plus 16 in there. Okay, divided by 2a, so 4. So look at this. Look at kind of the symmetry of the x-intercepts here. It's at -1/4. See that part of it? Plus or minus this part, which is roughly 1. Did everybody see that? That's roughly 1. That's square root of almost 16 over 4. Kind of basically, it's roughly 1. So now I see that I've got x-intercepts at about -4 and left 1. So there, and at -4, and right 1, so about here. And these are about, just getting the general idea. Okay? So it's just, I'm just analyzing the quadratic formula and the way that it shows a symmetrical answer. And that's the key to that one. Okay. Hang on, I've just got to move on here because I'm going to have the bell ring here in a second. So this is helping me get x-intercepts. Okay, how about the asymptotes? Everybody see difference of squares a mile away? Makes conjugate pairs, right? So 1 makes 0 downstairs. We've got -1, which is just inside of that intercept.
Also positive.
And +1. What's the horizontal? What's the horizontal? Big guy over big guy, right? So most powerful thing over most powerful thing. We got 2x squared over x squared. That reduces when x is a billion to basically 2. So this thing is going through 2. And we have the same kind of weird moment where an intercept is on a horizontal asymptote. How did we handle that before? Did we figure that out? Okay, it's okay, right? We can cross horizontal asymptotes locally. Okay, and there's actually asymptotes you cross infinite times as you're approaching it. But let's not go down that path. Let's just try to get as much of the graph as we can. See the dot here and the dot here? We've got this intercept and this intercept. I'm going to go ahead and assume some sort of cubic looking thing in here. Okay? I may be a little bit off, but with the bell ringing here, I just want to say, you know, there's a good chance. I'm not going to be picky if this is right or wrong at this moment. We're not in calculus yet. We're getting there. Over here, I got an intercept on this side, so that guarantees. Is it up top? Is this graph exist up here with this intercept? No, get rid of that graph. That graph doesn't exist there. It's got to exist down here. Okay, now, the other part of the graph is over here on the right side, beyond x equal, and I always forget to write that. I should write that x equal 1's asymptote. Why is it on the upper one?
Because it wouldn't be very good looking.
So if you plug and chug, here's the catch. Is it going to be bigger than 2 or lower than 2 at big numbers? Okay, and it's kind of hard to do. It takes a little bit of plugging and chugging big numbers or just abstract trying to think about that. So would you say if I plugged in real big numbers like a billion that the plus billion here makes the top bigger? See this x right here? I bet you if I plug in a billion, I'm going to get 2 billion squared plus another billion where the bottom doesn't have that plus billion, does it? So the bottom is always slightly bigger with the 2. That makes sense. The top, excuse me, the top. I said that wrong. Thank you very much. So the top is going to be bigger with the 2. So what is that? Does that help with fractions?
It's going to be bigger, so we just over on the top.
Yeah, good. So let's go ahead and do this. There's one other way. One other way. Remember, almost done, almost done. I could take a quick look. I wouldn't recommend doing the whole thing. I could take a quick look at how it divides in. And if it divides in by going by 2, and I know it goes 2x squared minus 2, okay, bring down, okay, and double check. What happens here on the next point? We get an x, okay, and we get what?
-4.
Just x it looks like, doesn't it? Did I do that right? Okay, did I multiply right? Did I subtract right? I think I did. So what's left? It's plus x over x squared minus 1. So if I take 2 and I add a billion over a billion squared, that's roughly adding a little. The key sign is right here. That guarantees that the graph is above the 2 lines because it's 2 and a little. Does that make sense? Okay, but that's because if I plug and chug a positive x, that's a positive value. Does that make sense? So that guarantees it.